Today, I want to show you a project I've built over the past weekend, a Breadboard weather station. I know, to some of you, this just looks like a mess of wires and batteries, but trust me, this is the beginning of something much bigger. If you've been watching my channel for a while, you may remember that a few months ago, I published a video about a weather station I was designing, one I planned to bring to the market. The last update on the project was back in November 2025, 4 months ago. After that video, I put the idea aside and focused on other priorities. But now I'm back in the game, and I'm willing to work as hard as I can to turn this project into a real product. And of course, get rich, because let's be honest, we all want money, right? So to get things moving again, I decided to build a simple but functional version of the weather station I had in mind. The goal of this prototype: test the wireless communication capability of the project. In other words, test the LoRa modules. This time I used the RULR 993 lit modules. They are manufactured by Rayex, a Taiwanese company that focuses on wireless solutions for IoT applications. They kindly provided the LoRa modules for this prototype, and they are also the sponsor of this video. I have to say, I'm pretty satisfied with the results I got. But I will talk more about that later. If you are working on a project that needs wireless communication like LoRa, GPS, Bluetooth, 4G, etc., I highly recommend you check out their products. Rayex has distributors worldwide, so you can access their solutions no matter where you live. I've put the link in the description below. Thank you, Rayex, for sponsoring this video. Now let's get back to the project. To make this work, I used two Arduino boards. One acts as the transmitter. It collects weather data and sends it to the user. The other board has an LCD screen that displays the data it receives. The communication between them happens through LoRa, which stands for long range. LoRa is a powerful technology very common in IoT applications. It lets devices communicate wirelessly over longer distances while consuming very little power. I won't dive deep into the theory here. I already did that in a previous video. If you want to learn more, I highly recommend you check it out. To build this project, I used the components you are seeing on your screen right now, in case you want to build it too. You can also check out the schematics for both the transmitter and receiver, also on your screen, so you know exactly how to wire everything up. You might have noticed that in addition to the LoRa modules, I picked a DHT11 sensor and a GPS module. The DHT11 sensor handles environmental monitoring, temperature and air humidity, and the GPS module locates the exact position of their station. Since it will be placed outside, knowing its global position will help make sure it doesn't get lost. Alright, I've talked a lot. Let's assemble everything. Now that it's done, it's time to upload the code I wrote. By the way, I open source everything. You can find the code in the GitHub repository, link in the description below. I tested the system inside my house. The weather station worked fine, but the GPS didn't. I rebooted, moved to different rooms, it's still nothing. So I searched online, and here's what I learned. The NeoSysM GPS module is pretty basic. It struggles to get the signal indoors because the roof and walls block the weak satellite signals. GPS needs a clear view of the sky, or at least a much better receiver to work inside. That is the lesson. don't expect cheap GPS modules to work indoors. Save yourself the frustration and just go outside from the store. So that is exactly what I did. I went to a square, turned on the transmitter and receiver, and a few seconds later, the weather station was working. I could finally see temperature and humidity readings on the LCD module. By pressing a button, I could also switch from Celsius to Fahrenheit and back. The GPS started working too, but it took about 5 minutes to lock onto satellite signals. That is normal for this receiver. It needs time to download orbital data. Still, for a cheap GPS, the results are pretty good. I checked the current position on Google Maps and the coordinates from both systems matched. So if I ever lose the transmitter, I will be able to find it. I spent half an hour testing this first version. The results gave me some good ideas for a second version, something closer to the final product I am envisioning. I am still in the prototype phase, but I want to finish this as soon as possible so I can launch the weather station to the market. I didn't do a full range test today, but I want to do one in the future. I've watched some YouTube videos about the RULR993 Lite module. In some range tests, creators claim that in good conditions, open field, good weather, strong antenna, the signal can go up to 20 km, that is about 12.4 miles. But I'm thinking, what about a range test in a city? Lots of obstacles like cars, trees, and buildings that would tell us how LoRa really behaves in real-world conditions. If you'd like to see that on my channel, let me know in the comments below. By the way, I've got some emails from you guys asking me to help with your projects. So I decided to open one-on-one consultations. If you are interested in hopping on a call with me to talk more about your project, you can book it through the link in the description below. That's it for today's video. I hope you like it and learned something useful for your own projects. If you want to see more content like this, hit subscribe. That way you get notified every time I post a new video. And before the next tutorial comes out, I recommend you watch the video that's appearing on your screen right now. It's the first episode of my journey about building a hardware product from scratch. I'm sure it can help you on your entrepreneurial journey too. Thanks for watching all the way to the end. I will see you in the next one.